Okay, so now becomes the we move on to the second problem here. The second problem is given that we have a force vector here and we know the point of action of the force here, and we are supposed to determine the the moment of the force about the axis here is the axis, and then they determine the shortest distance between the force and the z-axis. Well, how we can approach that? So first, the moment of the force about z. Okay. So to evaluate that, we know that it can be evaluated by a determinant, right? Okay. So actually, that determinant is essentially projecting the moment vector which is actually r cross f to the axis, and here actually it is a z-axis, and the unit vector defining the direction of z-axis is k vector. Typically, it is like that. Okay, so here please note that r is what? R is actually a position vector from a point on the axis, right? So here typically we can take the point of the origin, right? It is definitely on the axis to any point on the line of action. For example, the point of action here, right? So we have R here. Here. So we are gonna have R equals to 3I plus 3J, right? Here. And now we know that, so this operation here, I actually it is the first have a cross product, and then it is a dot product here. So it can be expressed as it can be expressed as a determinant, right? So that is actually in our appendix. Okay, so moment of a force about an axis. So we already have here. And here the first row. Okay, so the first row is the three components of the unit y vector along the axis. Second row is actually our r vectors, and the third row is actually the force vector here, right? Okay, so now we go back. That will be okay. So the first row will be the three. So the first row will be the three components of the unit vector along the axis, which is actually, since it is z-axis, and the unit vector is k. So the I component of k is 0. J component of k is 0. K component of k, it is itself, it is 1, right? Okay, so the second row here will be the three components of our R, right? So it is 3, 3, 0. Okay. So the third row will be the three components of the four force here, right? So it is a 1, -3, 2, right? Okay. So if we find out the okay, if we go ahead to evaluate the determinant here, we which will be okay, since my x component and j component here, the corresponding number are zeros, we can we can just ignore them and focus on k component, which is actually 1 times the subblock, excluding the third row, excluding the first row and third column here. And you have the product of the diagonal minus the product of that diagonal here, which is actually 3 times -3 minus 3 times 1. Okay. So, and you have it equals to, okay, it is -12, right? It's -12. by seeing negative 12, we mean that it is actually rotating about z uh by clockwise if you are looking from the positive side of z here. Okay, so now we are supposed to determine the shortest distance between between our force and the z-axis. And so it looks like it is actually examining our it is a problem of geometric problem. However, it is actually examining uh our concept of moment equals to moment can also be calculated by the product of the magnitude of force and the moment arm here. So the moment, the magnitude of the moment equals to the magnitude of force times the a distance d here. It is typically called moment arm. So here it is actually the distance from the line of action. It is distance from a line of action to the axis. Okay, so that is actually our d, and which is the distance that is asked here. So the shortest distance between the axis of force and the z-axis is essentially the moment arm here. Okay. So based on this, we have d equals to magnitude of the moment of force about z-axis divided by the magnitude of force here, right? So the magnitude of the moment of force about z equals to 12, right? Okay. So the magnitude of force here is given that we have already know the Cartesian format of force. So the magnitude of force will be summation of the squares of the components and the square root of that. So the unit will still be, and then you can evaluate that. It will equals to, so 12 divided by summation squares of the components, right? Okay, that's 3.2, right? 3.2 feet. 3.2 feet here. Okay, so that is actually the answer of our sets. That is the actually the answer of our second question here. Okay.